Hello everyone, in this video I'm going to show you how to control a DC motor in forward and reverse direction using UART and PWM. If you want to follow along, please build your circuit based on this diagram before starting. Well, these are the entire step to take to rotate the motor, but let's focus on UART and timer 2 first. Other than that, other settings in Cube IDE are just basic setup, so you can simply follow along step by step later on. First of all, UART. We're going to use the UART2 with the asynchronous mode, and we're going to use the baud rate with 115200. Now the key part is timer 2 for 500 Hz PWM over here. Timer 2 runs at 72 megahertz from APV1, as you can see over here, the clock tree. So we're gonna set the prescaler to 71. This divides 72 megahertz by 72, giving us 1 megahertz. And then we're gonna set the counter period to 1999. So the calculation becomes like this after all. So that's how we get the 500 Hertz PWM. And this is the appropriate frequency to rotate the DC motor. And then additionally, remember that the duty cycle value directly controls the motor speed. By changing the CCR value, we adjust how much power is delivered to the motor. Everything else is basic configuration like I said before, so just follow my screen. Here we go. Well, open up the STM32 Cube IDE, click File, New STM32 Project. And you can select the board. Mine is STM32 F103C8T6. There we go. Click Next. And I'm going to write down the project name as UART. Click Finish. Well, now the project is made. Well, now we're going to move on to step 2. So first things first, we're going to set the RCC high-speed clock to use the APV1 timer clock as 72 megahertz. And we're gonna set up the debugger with the serial wire. And we're gonna use the UART2 with the asynchronous mode. Make sure that the baud rate is 115200, like I said before. And we're gonna go to the clock configuration part. Like I said before, I'm gonna make the 72 megahertz frequency, and so that we can make the APV1 timer clocks as 72 megahertz. And now we're gonna move on to the timer setting. We're gonna use the timer 2 with channel 2. Before we do that, the clock source would be internal clock, and with the channel, we're going to use the channel 2 and click PWM generation channel 2 over here. And like I said before, we're going to set the prescaler to 71, and the counter period must be 1999. There we go. And then we're gonna set the GPIO output PA10 and PA11 to decide the direction of the motor. It could be reverse or forward to control those two pins. So yeah, this is all about the setup, STM32 IDE setup. So we're gonna click the code generation icon. Click yes. Now the code is made. Well, to keep the main C file clean and well organized, we're gonna create separate header and source files for the motor and UART modules. So click core. Inside of the include folder, we're gonna make the header file for UART header. And then again, click header file for motor header. And when it comes to source folder, we're gonna make the C file, the source file, I mean, UART C. And then again, motor C. There we go. Well, first things first, we need the standard input-output header file for sprintf function. And on top of that, we need string header file for string length function. And we need standard library header file for transforming string to the integer type. Other than that, we need to include the main header file all the time. And I'm gonna make the UART initialization function, and we need a handler type definition handler UART, and we need the send string function, and we need the UART read line function as well. And I'm going to include the next length as well. Next length. And maybe we need the clamp value. For the parameter, it could be value, minimum value, and maximum value. We're going to clamp the value from negative 1999 to 1999. These are the values of the speed of the motor. So there we go. Well, I'm gonna complete the UART file. First things first, I'm gonna include the UART header file, and I need static UART handle type definition, the pointer type variable, motor UART handler, and I'm gonna complete these functions. For the initialization part, I'm gonna directly write down the UART handler parameter variable to the motor UART handler variable. So when it comes to send string function, we need the transmit related function. Transmit motor UART handler, and 1 byte pointer type variable string and string, and I'm gonna wait the amount of half max delay. There we go. And then when it comes to read line, I'm gonna make the code later. I'm gonna complete the clamp value function first. If value is greater than max value, I'm gonna return max value. If value is smaller than minimum value, I'm gonna return minimum value. Other than that, I'm gonna return value right away. And I'm gonna complete the read line function. We need 1 byte variable because UART is basically 1 byte communication. And we need the index as well. I'm gonna make the infinite loop over here, but if we reach but when we receive the 1 byte variable, this means a 1 byte. I'm gonna wait how max delay. If this function returns how okay, then in this case we're gonna check the each this variable, character variable. If we reach the carriage return or the line feed character, which means the end of string, this character means end of string. I'm gonna fill up the index with the null type, the null character right away. And I'm gonna return 1. If index is smaller than the value of max length subtract 1, which means that we need to fill up the buffer with the character like this. So yeah, this is all about the UART related code. So click save, and if I build this code, build is completed. Well, let's complete the motor related files. Well, first things first, like I said before, we need to include the main header file all the time. And I'm gonna include the standard library header file for the ABS function, because if a negative value is entered for reverse direction speed, we use the ABS function to remove the sign. And so from now on, we need the function for motor initialization with the timer handler type definition, and I'm gonna name it timer handler like this. And I need the set speed function with the parameter of speed, and I need the function for motor stop. There we go. Well, I'm gonna include the motor header file to complete the motor C file, and I need the static variable with the timer handler type definition, pointer type, motor timer handler variable, and I need to define some of the pins and ports for the motor driver. Motor PWM channel is timer channel 2. Based on this motor driver, there is the in1 pin. The port is GPIO-A, and when it comes to pin, this GPIO pin 10, and when it comes to in2 port, it is GPIO-A as well, but when it comes to pin, it must be 11. And I'm gonna define the motor max speed, which is 1,999, and we need to complete those functions. First things first, when it comes to motor initialization, I need to set up the motor timer handler variable with this parameter variable, and we need to start the timer PWM generation. Motor timer handler with this channel number, like this. There we go. And for the initialization, I'm gonna stop the motor at first. And when it comes to set speed, if speed is greater than the motor max speed, I'm gonna clamp the value like this. If speed is smaller than the negative motor max speed, which is minimum speed, I'm gonna clamp with the negative value like this. And if speed is exactly 0, I'm gonna call the motor stop function, and I'm gonna return it right away. Other than that, if speed is a positive value, I need to go forward, rotate the motor with the forward direction, call GPIO right pin, this port, and it must be pin for the second parameter, and GPIO pin set. And if I reset the second port, second pin, reset, then it goes forward. If the speed is the negative value, we have to rotate the motor in the reverse direction, so it must be opposite from the positive one. So it's gonna be reset, it's gonna be set like this. And after that, we need to call the how timer set compare function. Motor timer handler with the motor PWM channel with the speed of, speed without the sign, like this. So, and lastly, when it comes to motor stop function, I'm gonna, make those direction related pins to all reset. This is how we stop the motor. And just in case, I'm gonna set compare using the compare function, throw in the value 0 like this. So this is how we make the motor related function. Click save, and if I build this code, the build is completed. So this is how the flowchart works before we dive into the main C file. First things first, we're gonna enter the speed value to rotate the motor. And if we don't receive anything, we're gonna wait until we receive something. If we ended up receiving something, we're gonna rotate the motor and print the speed value. And then we're gonna go up to the beginning again and then do this process over and over. So this is how it works. Now it's time to complete this main C file. First things first, we're gonna include the UART header file. We're gonna include the motor header file. And then we need the buffer. The input buffer size would be 32 bytes. I'm gonna make this big enough just in case. I'm gonna name it RX buffer with the input buffer size. And we need to initialize the UART and motor. In this case, we need to throw in the UART handler 2 and timer handler 2. There we go. Yeah, so just to make sure that those function exist. So first things first, we're gonna enter value. So UART send string, enter value from negative 1999 to 1999. And after that, we're gonna check whether we receive anything. We need to UART read line function with the RX buffer with the input buffer size. If this function returns 1, which means that received something. In this case, we need to transform the string to the integer type variable. And we need to clamp the value first. Clamp value. It's gonna be negative 999, 1999, which is minimum value and maximum value. There we go. And then we need to rotate the motor using motor set speed function. And I'm gonna print out the value. I'm gonna make this buffer size large enough. And we're gonna throw in the string clamp value into this tx buffer variable. After that, we're gonna print out the tx buffer. So to sum up, this is how we rotate the motor, and this is how we print value. So there we go. And this is all about the coding part. So click save if I build this project. Build is completed without any other errors. So there we go. Now I connected all the cables, USB cables, into my laptop, and then I'm gonna click the run button. Click OK. There we go. So now I'm gonna open up the session for the serial communication, and you can check your port number in your device manager, but mine is COM4 and the baud rate is 115200. Click OK, connect. I'm gonna test with 2000 for negative 1700 or 0. Well, I'm gonna show you this situation for real. So let's start with full speed and reverse the motor with the same speed. I'm gonna stop it. How about 1500? It got a little bit slower. I'm gonna throw in negative 1500. How about 1800? $1,100. And I'm gonna reverse the direction. Negative 1800. Negative 1500. 1200. How about clamping? The clamping works, as you can see. Yeah, there we go. Well, this is all about today's video. You now have full control over your DC motor, speed, direction, all from a single serial command. Keep building, keep experimenting, and I'll see you in the next one. Bye guys.